Hey everyone, I'm Won Lee. We are talking about interval estimation. It is necessary to know what confidence level is, okay? And I said it is starting point to understand uh, confidence estimation for population mean mu, okay? And today, what is 1 minus alpha 100% confidence interval for mu? It is important part, okay? Let's see just shortly. Okay, confidence level. I think you understand confidence level up here and the confidence level of 1 minus alpha 100%. 1 minus alpha 100%. Why we use 1 minus alpha? Okay, because it is related with next main topic, hypothesis test. So we used to use confidence level of 1 minus alpha 100%. Okay, estimation confidence interval for population mean mu, x bar should be used. We have to use x bar, okay, because it is best estimator. What is the distribution of x bar? By central limit theorem, x bar has a normal distribution with mean mu variance sigma square over n. And standardized it, then g, we get g, x bar minus mu over sigma divided by the square root of n, like this. Okay? So we will use this distribution. So we need to drop 1 minus alpha in center of this graph. Okay, 1 minus alpha here. Then both tails have alpha over 2 probability. Okay, now same thing, same graph here. So this graph is G, capital G is random variable. G lies between minus G alpha over 2 and plus G alpha over 2 is the probability is 1 minus alpha. So this equation says this graph, right? You may easily understand this kind of a thing. Then what is G? G is x bar minus mu divided by sigma over square root of n, right? Same equation. Then it will be x bar minus mu rise minus g alpha over 2 sigma over square root of n, g alpha over 2 sigma over square root of n by multiplying this term to each 1 minus alpha. Then subtract x bar from each part, minus x bar minus g here, minus x bar plus g alpha over 2 here, and here minus mu left. Then multiply by minus 1. Then multiply minus 1 here, then it's going to be to the left. And minus 1, this one times minus 1 comes to here. So what is this? This is probability of mu being between from here to here is 1 minus alpha. So that is just a confidence interval. So 1 minus alpha 100% confidence interval for mu is same thing. This result, I think, is very important to understand interval estimation and confidence interval, and hypothesis test. This part will be applied on hypothesis test. And another thing is, if you understand this process, okay, so the result here, this process, then you may understand other parameters easily. Say other parameters is P and sigma square. Same logic will be applied to these two parameters. So that's why I emphasize statistics very simple, straightforward, okay, systematic. Okay, however, let me let me talk about this one. The reason for placing alpha over 2 in both tails alpha over 2 is that assigning alpha over 2 to each tail minimize the width of confidence interval. You have to get the confidence interval as much as short, right? If this way, alpha over 2, then the length width of interval is bigger than this original. Is it original? Anyway, interval, this interval is shortest because it is a symmetric distribution. Okay? And another thing is we do not know sigma value of sigma, because it's population standard deviation. So we have to estimate sigma, another thing. Okay? Yeah, I'm gonna explain about it next time. And let's see simple example, because it is a very important part, I think. Now, let's derive the confidence interval for mu at 95% confidence level. When alpha equal 0.05, then 95% confidence level. Then, what is that? Standardized normal here, G, then here. What is 0.025? Then this part gonna be 0.475. So 475, let's see here. Okay, what is G? Value of G, 1.96. So this value is 1.96. This 1.96 is, say, important, say, good value for standardized normal, because we used to use this alpha is 0.05. Okay, then instead of g small g alpha over 2, we use 1.96. That's it. But as I mentioned just before, we do not know sigma. We have to estimate sigma by what? S, right? Sample standard deviation. Okay, I hope you may understand it easily, and we are ready to go further. Thank you. This is it. Bye.